Welcome to the shop. In this video, I'm going to be completing the machining for the sculpture and probably make another video for the wood base. I'm not sure. I make this up as I go. I don't have a grand plan overall, and I try to separate things kind of sort of by just what makes sense. So I'm going to start off making a really simple little part that almost doesn't matter at all, but for sake of completeness I'm going to show it. This is a little aluminum ring that the arms that I made in the previous video will screw to, and then the arms of course hold the hexagonal glass piece. Now for this piece, since I'm only making one, I could make it on the Bridgeport, but because of certain technical details, it's faster and easier to make it on the mini-mill, or at least do the first operation on the mini-mill, and then I'll do the second operation on the Bridgeport. It's really nice to have both machines because some things are faster on the mini-mill, some things are faster on the Bridgeport, some things are easier on the Bridgeport, especially when only doing one part. So I'm glad I have both. Gonna clamp the little part in the vise, and if you remember from the last video where I was talking about equalizing clamping force, well, every rule has an exception. In this case, I'm only drilling tiny holes. I'm not clamping it really tight. I'm not doing heavy machining. I'm only making one part, and it'll be fine. So, already got the tools loaded. And this one is not a very interesting part, but you know, they all are important. So I'm going to start out drilling a little array of holes. Going to drill 6 little holes, and these are going to be the clearance holes for the 256 screws that hold the arms in place. This ring and arm assembly that I'm making, I've got future plans for it as a kind of a universal holder for hexagonal glass in future sculptures. So I'm actually planning on reusing the design a little bit. The screw that I'm going to be using is a socket head screw, so I need to make a counter bore. I'm going to do that with an 1/8 inch end mill since I don't have a precise size cutter that I can just do it in a single plunge cut. I'm just interpolating a circle with a little end mill, and works perfectly. And then drill a center hole for the mounting screw in the center. And finally use my favorite new tool, the blower. So it's not a very interesting part. You get this like that, get the light on it. Not a very interesting part, but even the little guys are all essential, gotta get them done. So for the next step, I'm going to be making the fixture and machining the perimeter on the Bridgeport. And like I said, sometimes the mini-mill is the best choice, sometimes the Bridgeport is the best choice. In this case, I don't currently have set up in the tool holders, I don't currently have set up a 256 drill and a 256 tap. And since I don't use them that frequently, it's not really worth dedicating a tool holder to it. And it's like super easy to do on the Bridgeport, so I'm going to go over to the Bridgeport and continue the process. So now I'm going to drill some holes in a small piece of scrap aluminum to act as a fixture for this little ring. And I could very easily just type in the coordinates on the Bridgeport and not write a program, but I already had the drawing loaded and it only took a minute. And once again, there's more than one way to do things, and I often do things different ways. So I've got the 0 set on the machine, and of course the Bridgeport is on the network, so I don't need to use a USB drive or a floppy disk or anything else that other people need to put up with in CNC machining. So let's get to the first hole location. This is going to be another one of the little holes. It's going to be a 256 tap drill. So power drawbar is very nice, very convenient. Get that stop out of the way. I had that set up for the other operation, so I believe everything is ready to go. I'm going to grab a little bit of the Tap Magic cutting fluid and peck gently. These little tiny drills don't have a whole lot of chip clearance, and when drilling aluminum, the biggest cause of, and I think I better move my parallel out of the way, unlike my soft jaws on the MiniMill, gotta be careful about parallels on this guy. The tiny little drill bits, well actually any drill bit, the biggest cause of breaking tools when drilling or working with aluminum is chip buildup. So I'm being very aware of chip buildup here. Blow off the little drill bit, make sure I have a little bit of cutting fluid, and just be oh so careful. So, for larger holes, I typically power tap on the Bridgeport, but for a 256, I'm just a tiny bit concerned about that. So I'll go ahead and hand tap them, and it's not very interesting. So turn the camera off and then come back when it's set up, and then I'm going to mill the profile. So a quick trip off to the office, to the CAD computer, and I've got my profile program. I've got my little part attached with 3 little 256 screws, and I'm going to be doing the outer profile using a 3/8 inch 3-flute solid carbide milling cutter. And one of the nice things, let me set my 0 here, because unlike the MiniMill where the tool lengths are stored in the program memory, and every time I put a tool or a tool holder in the spindle. The machine knows what the length is. For this guy, I have to do it manually, so I just set 0 to be at the surface of the fixture. And one of the nice things about 2-axis machining is that, well, with 3-axis machining, once you push the start button, the machine is going to do what the machine is going to do. And even if you're really, really careful, and even if you have your finger on the stop button and you're paying attention and you got the feed slowed down and you got the rapid slowed down, things can go wrong before your finger hits the button and pushes it in. And that's why running a program for the very first time on a fully 3-axis machine is always a little bit scary. On a 2-axis machine, I control the Z by hand, so I can just go over here and start the program and see that it does a rapid to the exact place that I thought it was, have the tool out of the way in a safe area, start the program, observe that, yep, looking real good. I believe this will be a success. So now I'm going to do it for real. Use the mist coolant system. There we go. And I think I could easily do this in one pass, but might as well take it easy. Not doing production. Real fast to do it in 2 passes. So that is a nice little outer profile. And next thing I'm going to do is make the center counter bore. So once again, the machine is on the network, so I just call up the program. I do have a counter bore for a 632, which is the center hole. And I'll set my Z, and looking at the DRO, and there it is. A nice little counterboard ring that the little arms will attach to like that, and then hold the hex. So that wasn't a very interesting part. The next one should be a tiny bit more interesting. I'm actually gonna mill this next one out of 1/2-inch aluminum because it's a different design that I haven't tried before, and kind of think that 1/2-inch might look kind of cool. It's going to be the large element that comes up along the back and holds the hex in place, and it'll be the first one where I actually angle the hex a tiny bit because I think it might look cool. So it's all an experiment. Every one of these I do is an experiment. I've never done 2 in a row exactly the same. Not even sure I could do 2 in a row exactly the same if I tried. The metal parts would be easy, but the glass, no, the glass always does what the glass does. So I'm going to turn the camera off and get ready for the programming of the next one, and then turn the camera back on for the next piece. So see you later. Okay, the parts are made, and I took a still photograph of the kind of proof of concept assembly just to show how the glass hexagon fits in. It fits really good. So next step, I'm going to be making the frame member. And one of the tricky things about doing mechanical parts is trying to figure out what to call it. And I don't know, frame member isn't quite right, and I don't know, support structure thingy in the back, spine, backbone, I don't know, it's a thing, it's made out of metal. So this thing that I'm going to be making is kind of big, and in order to kind of control it, I've got it sitting in the left vise, and the unsupported end is held in the right vise. Now this is all intentional, this is all by design, that when I set up the vices in the machine, I indicate them both to be like precisely in line, and of course the jaws are all made on the machine, and so the jaws are all accurate, the vices are all set up accurate, so I can take a piece and put it in, and it'll accurately line up. So this is going to be the first run of a new program, and as always, I gotta be careful. Load this, and then I'm looking here on my comment on the G-code to see that yes, it was done at the right time, on the right date. Always double check, always cross check. And yeah, this is a complex enough part that it makes sense to do it on the mini mill. There's a bunch of interesting things going on. I am going to be making it out of 1/2-inch thick aluminum, which is the first time I've ever used thick aluminum on one of my sculptures, and I think it'll turn out pretty good. But the good news is that after a number of years and thousands of parts, I'm getting pretty fast at this, and I have a pretty good success rate, but still, as they say in aviation, once a pilot thinks they know it all, they're the most dangerous pilot in the sky. So I still got to be careful, even though I'm very optimistic that everything's fine, I'm not going to have any problems, but I still need to treat every time I run a program as doing it for the first time, and just be careful. So got the option stop. And I'm going to be grabbing the first tool, check the label on the tool, check the user interface, make sure the taper is clean, and single block mode, 25% rapid. And the first thing I notice is that it's in the correct place. This is a different work offset than I usually use, so I'm just checking to see the work offset is correct. The pre-positioning looks correct. And I'm going to be, this is all looking pretty good, so going to be pecking with the 1/4-inch 3-flute end mill, and then after the hole is cut, it's enlarged a little bit by moving around in a circular interpolated pattern. And first 3 holes are looking good. Now the next holes get a little bigger, so I'm going to use a bigger cutter. I tend to not like to use 1/4-inch cutters unless I need a 1/4-inch cutter. Same thing with the 1/8. A 3/8 cutter is a pretty heavy-duty cutter, and you can pretty much do anything with a 3/8 cutter. So single block, 25%. Also, typically in one of these designs, if the first operation, if the first tool works correctly, it's really likely the rest of them are going to work correctly too. So, but still, step by step. Don't get too confident, especially on video. Looking totally reasonable. Take it off single block. Going to be doing a ramp entry. Followed by the perimeter pass. And I'm intentionally doing this to not leave a slug in the middle, because trying to do a cutout like this with a slug in the middle doing just a profile is oftentimes leads to trouble, because the slug gets caught on the cutter. If I'm lucky, it just flings it out. If I'm not lucky, it breaks the cutter and ruins the part. So for any of these smaller, actually for any of these internal cutouts, I always just turn them into chips. So kind of don't like the way this taper looks. I always check every taper just to make sure it looks clean, doesn't have any scum on it. I don't want my spindle to get all scummed up. Checking offset 13. So while I was talking, I picked the wrong tool. So double check, cross check, check the check, check again. Tool 13, taper looks fine. This will be a drilled hole. A very little hole. Doing a small peck. And that's looking entirely reasonable. Now, I'm going to put in the one that I cleaned, tool number 5, which is an 1/8 inch end mill. And just gonna check the tool path one more time on this guy. 1/8 inch end mills are troublesome little guys. Yep. I'm pretty confident my tool path is right. Let's give this guy a try. Single block. Looks like it's in approximately the right place. And everything is looking good. I'm starting off with a peck cycle, very slow. Then that's going to be followed. Oh, I guess I'm done. Going to be followed by a circular interpolation. Yeah, that actually looks correct. So now, I'm going to be using a 1/4 inch cutter to cut out the pocket. I kind of chose the 1/4 inch cutter because I'm still making this up as I'm going, and I'm not sure that I'm going to like it, but I'm trying to incorporate the tool marks from the cutting operation into the design, partly because it's just really, really hard to polish out tool marks on the inside of a cutout like this, and also because, they kind of look cool, maybe, I don't know. So, anyway, there's a chance that it would have looked better if I used a 3/8 cutter, but I'm just going to try it this way. That is looking good. Take it off single block. Now for a lot of this pocket, I'm going to be cutting air. And this is also by design. And Just checking to see everything's correct. I wanted to cut the holes first and then cut the pocket because that gives a nice, clean, crisp, burr-free edge, or if not burr-free, at least the burr is manageable, as opposed to cutting the pocket first and then cutting the holes and having to contend with whatever burr comes out of the holes, because actually cutting the pocket makes a either no burr or a very, very small, very manageable burr. So, looks like it's working well. I have great confidence that this will be a successful pattern. And this piece, very much like the arms, I'm going to have to make a fixture to hold this in place to do the profile, then put it in the Bridgeport for 2 drilling operations, and at that point the machine work will be complete. And once again, when I'm doing production for my production parts on the Inquala, I optimize tool paths to try to get things to run a little faster, to reduce cycle time. Let me stop talking for a minute and follow the procedure. This is the last step on this side, and I don't want to get too confident and then make a stupid mistake. Yeah, it's looking real good. Take it off single block. And this is going to be the 1/8 inch cutter to clean up all the inside radii, because I want the inside radii to be really, really small. And I actually forgot what I was talking about, so it must not have been that important. But yeah, there it goes. Oh, I was talking about optimization, and here's a perfect example of optimization, that on my production parts, when I'm doing thousands of them, I do a fair amount of work to optimize and reduce cycle time. I can't say that I have the perfect cycle time, and there's always room for improvement in just about everything, but they're optimized to go pretty darn fast. For one-offs, when there's a chance of breaking a cutter and ruining a part, I always go really, really, really slow, really slow. And did I say really slow? Maybe I should say it really slowly. So, just better to be slow than to break a cutter. I'm sure I could go a lot faster, but actually by the book, when you're doing, it's a small diameter cutter, so I want to run it as fast as possible, which would be 10,000 RPM on this spindle. And then as far as chip load per tooth, it's actually running at 1,000th chip load per tooth, which is the recommended chip load for starting off on a conservative tool path. So probably couldn't do it a whole lot faster, even if it was optimized. Now here comes the fun part. So that appears to be a completely... Now, I don't know if you can see the tool marks that I was trying to achieve. I kind of like that effect. It's not completely under control, but you know, it's kind of almost cool, maybe. So going to go back into the CAD room and do the toolpath for the other side, turn off the camera, and come back when I'm ready. Toolpath is finished. Let's make some chips. I've reset the 0, so using yet another work offset, take the part, flip it over, because I wanted reference 0 to always be this corner, so simply flipping the part over this way would not keep the same reference. So I'm keeping reference 0 here, have reset and reprobed and remeasured off camera because, hey, you've seen probing before. So really nice having the machine on the network and having the office right next to the shop makes things really convenient. So standard operating procedure, option stop, check to see tool number 1, single block, slow it down, going into what appears to be a reasonable place. And take it off single block. And all is looking well. Once again, I'm using a small cutter because I kind of like the tool marks. Who knows? I'll probably try one with a bigger cutter too, and just see which one I like better. Or maybe I'll learn to polish out the center of these things and have no tool marks, so it doesn't matter. But yeah, all is going well. After this operation, I have a couple of, well, I need to make the fixture using a similar scheme as before to make a mating island that fits the cutout. Then after making the fixture, put it in place and mill the perimeter. And then after the perimeter, then there's a couple of holes to drill. And then project will be almost finished. All looking correct. Looking good. And kind of running out of things to say. This is a really slow operation, and not even sure it's worth finishing. So I think you can probably guess how it's going to end. So I'm just going to turn off the camera now, go back in the CAD room, and start planning the next operation. So I'm going to let it run. So the toolpath is constructed. I found a piece of scrap aluminum. It's not quite the right size, but it's going to be close enough to accomplish the needed function. So I'm going to make a fixture. This is a similar fixture to the fixtures I used on the arms. And once again, it's demonstrating how much work there is. An awful lot of machining. The first one is the expensive one. The first one takes the time, and once you get the toolpath and the fixtures and everything taken care of, the next 1,000 are easy. Of course, I'm only making one here. If I like it, I might make another one. If I really like it, I might make another one. Who knows? Maybe someday I'll even sell one. But once again, I'm very confident that all will be well and it will work great, but I'm still going to follow the procedure. Be careful. Pre-feed looks reasonable. And that all looks reasonable. Take it off single block. And going to be using a 1/2 inch end mill, a 1/2 inch 3-flute end mill. And it's kind of interesting that Haas kind of used a marketing tactic on me that appears to have worked. That when I bought the MiniMill, they said, oh, by the way, here's a $500 credit to buy Haas tooling. So, hey, 500 bucks for free, why not? So I bought a bunch of Haas tooling, a bunch of Haas end mills, and they work just fine. Haas tooling is great. I've kind of heard a rumor, I'm not sure of it, that it's obviously not made in America, but I shouldn't say obviously. For anybody that looks at the prices on these things, you would say obviously not made in America, but they aren't Chinese. I've actually heard a rumor that they were Korean, and they seem to be excellent quality. They seem to work fine, and so far, I think I'm doing pretty good. And I believe that I'm going to need a little bit of modification to this tool path, very possibly to make it fit. As I'm watching it, I'm thinking that, yeah, there's something special about this tool path, and I'm probably going to need to make a mod, but not sure it's going to be a problem. Just needs a mod. And let's go over here to single block. Going to be drilling the one mounting hole. 1/4 20, all looks well. Peck, 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 peck. Then the tap, number 34 tap. Power tapping on the Haas is just wonderful, works perfectly. So that is the part, and the tiny mod that I was talking about, I'm going to just turn the camera off and do it without the camera on because that part wasn't that interesting to begin with, and the mod is even less interesting. So I'll come back and show the profile. So the little mod went perfectly fine. It was just correcting for the radius. When I'm making an outside corner, it can be sharp. When I'm making a mating inside corner, it's got a radius, so I had to take care of that. The part fits perfectly, really nice and secure on the fixture with no slop, no motion. I've got a screw and a large washer here holding it down, but the hold down doesn't do much other than keeps it from pulling up. The side-to-side motion and all the cutting forces are pretty much taken by the fixture. So, going to be running the perimeter now, and I've already reconfigured the 0 to be on the surface of the tooling plate and not on the bottom of the part. And, you know, you've seen me probe before, so I don't want to waste too much time doing repetitive things. So frame profile, and this one is going to be using the aluminum shredder, the 3-flute aluminum roughing cutter, and I'm also like I said before, I'm going to be just cutting this as a profile because it's an outside profile where I don't have to worry about the inner slug getting caught and breaking the cutter. In my experience, the outside profiles tend to work pretty well. They do drop. The waste piece that drops off would get caught in the chip conveyor, and I'm going to probably have to reach into the machine and fish it out so it doesn't get caught. But it's, for a one-off part, it's a little bit faster than doing a full HSM. Oh, and for those who don't know, HSM, the acronym, means high-speed machining. So, once again, single block, reduced rapid, going over to the start position, observing it's approximately correct. The pre-feed looks correct. Feeding into position. Even though I could probably do a ½ inch in one pass, this roughing cutter is just amazingly aggressive. It just goes through aluminum like crazy. I'm going to do it in 2 passes just because. Really cuts really smoothly, produces super fine chips. And the nice thing about super fine chips, okay, there goes a piece. The nice thing about super fine chips is that they are evacuated. Oh, that one just fell off so nicely. Didn't fly, just fell. Don't even have to go into the bottom of the machine and pick it out, and that one was fine too. So before I switch to the roughing cutter, I'm going to take the 2 waste pieces out, and then I'm going to grab the roughing, or grab the finish cutter, because the roughing cutter makes, as you can imagine, a rough cut. And now the finish pass. Everything is looking good. I have great optimism that this design is going to be really nice. And it's the kind of the first prototype concept for a family of designs that are going to be far more elaborate. So there we are. The part looks perfect. Looks exactly how I wanted it to look. The washer didn't scar the surface. And that is the part. So, got a couple of more operations to do. I need to poke a couple of holes here, poke a hole there. I'm not sure it's even worth showing that. It's just work on the Bridgeport, and you know, it's not that interesting. I don't know, I might show it, I might not, but if I don't show it, probably pretty easy to imagine what it would look like. So, yeah, I think I'll just end this one here. Thank you for watching. It's been fun.